And I want to do this for you now. Okay. So, give me a thumbs up when you're ready for me to take this off the screen. I'm not going to move it until everybody's given me a thumbs up. All right. 1, 2, 3, 4, 5, 6. All right. Let's wait a minute and then I'll ask for a thumbs up again, because where you're scattered all over my screen, I'm going to forget who gave me a thumbs up and who didn't.
Shower.
Alright, now give me a thumbs up if you're ready for me to move on. Give me a thumbs down if you're not. Alright, Gabe and Hunter, you're the only two I don't think I see. Okay. And Lala, do you know how to take a screenshot? Go ahead and take a quick screenshot, since I know that you just got to the school. All right. Okay. One of the joys of being upstairs. We're going to have a couple more sound effects. But that's going to be all right. Okay, so focused on finding the equation for the left endpoints, which in this case gives us the upper limit. Because remember, I told you this box method is not going to give us a perfect example, but if we find one where the boxes are just below the line and another one where the boxes are just above the line, then we give ourselves kind of a bookends that we know our function has to be, or our area has to be somewhere in between those two. What we found with the right endpoints happened to be the lower limit. Sometimes it'll switch back and forth which one's the upper and which one's the lower based on the shape of the graph. But in this case, it's the upper limit, and so that way we at least know our area of our function is somewhere inside these numbers. So, and just as a reminder, we're using the function negative x squared plus 5 from x equals 0 to x equals 2 using 5 rectangles. And so just as a reminder, once again, our delta x, we're going to take our upper x and our lower x and subtract them, the upper minus the lower, and then divide it by the number of rectangles we're dividing into. So that's going to stay the same. And we're going to plug it still into the function f of xi delta x from I equals 1 until n, where here our n is going to be 5. So the hardest part here is figuring out your xi term. Luckily, it's not going to be too bad on this problem. But that's going to be the part where you're going to have to be the most diligent on these problems and really think through what it is that you're doing and does it make sense. So, just to draw kind of a sloppy copy of the graph, I want something, again, where I plug in I equals 1, and I get x of 1 is equal to 0. And I want something where I plug in I equals 2, and get x of 2 equals 2/5. Before it was convenient because I could just say, I'm just going to plug in 2/5, I'm just going to plug in that delta x, and I get out the number I want. But this one, we're going to have to modify it slightly. We're still going to use the 2/5, and we're still going to use the I, but we're going to move everything to the left by 1 using our rules about horizontal shifts, like you did in pre-calculus. And so it's always going to be a good idea to check to make sure this works. If I plug in I equals 0, oh sorry, not I equals 0. If I plug in I equals 1, then I get 2/5 times 1 minus 1, which is 0. So that works out. If I plug in I equals 2, I get 2/5, 2 minus 1. So 2 minus 1 is 1. 1 times 2/5 is 2/5. So it's always going to be a very, very good idea to go back and double check your work to make sure it really is giving you the thing that you want. Yep, Satya, that's fine. Alright, so now we can plug it up, put it all together, and now the worst part that's left is the algebra. So, we have, again, I'm going to go ahead and put in the 5 here. Our f of xi delta x is going to be the sum of, and it's, again, a good idea not to try to rush yourself too much. Our function was negative x squared, except for let's not put in the x squared yet because we're going to plug something in there, squared plus 5, and then we're taking all of that times our delta x, which was 2/5, and where the xi is, we're going to plug in what xi equals. So that's going to be 2/5 I minus 1, and from here on out, it's an algebra problem. It's going to be not the prettiest algebra problem, but it's just an algebra problem. So let's see. Here's how I'm going to do it. And you might choose to do it a different way. That's okay. And I think it's still a good idea to show you how to do the algebra because it gets pretty messy otherwise. This 2/5, I'm going to pull that out front so I can deal with that later. I'm going to write out all my steps so I don't lose you. Because have you ever seen the cartoon with the two scientists and there's math, 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 and then it says, and then a miracle happens, and then math, 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 and the one professor says to the other one, I think you need to be a little more explicit here in step 2. I know I've been through plenty of classes where it's going so fast that you feel like, oh my goodness, just some miracle just happened and I can't follow along with what we're doing. So if I'm doing too many details for you, just know that is why. Alright, so, for example, I'm going to distribute the 2. That's okay because these are being multiplied together. That is a legal move. And as lazy as you might be, don't skip writing out steps. Because you're going to lose something if you try to skip. Alright, so we have I minus 1. This is a good time to pull out a box. And do I minus 1 times I minus 1. And this I is not the imaginary number, by the way. I apologize that we're using I for two different things in math. This I means index. So we want to leave it as an I. It's not the square root of negative 1. Okay, so let's see. I squared minus 2I plus 1. And then plus 5 on the outside. Let's see. Personally, I'm not going to worry about distributing that 4/5. I'm going to go ahead and break up my function into its two sums. Just this way I don't have to deal with fractions yet. Maybe something will simplify before I deal with fractions. I'm being very deliberate with my use of my parentheses, because that 2/5 on the front does need to get multiplied by everything, but the negative 4/25 only gets multiplied by the first sum.
Where did your plus signs come in the second?
Oh, they came from my imagination because I was in a hurry. Good catch, because that changes everything. Alright, and then to make this look a little bit more like the functions that we've dealt with before, actually at this point I am going to break it up because this is going to feel kind of long. Let's see, let's erase this equal sign first. Here, where I have the sum of this, I'm going to go ahead and break this up into separate sums so we can go back to the summation notation that I taught you last time. Okay, last time I taught you that the sum of from I to any number of I squared is going to equal the number of boxes times the number of boxes plus 1 times 2 times the number of boxes plus 1 all over 6. And I taught you that the sum of the first I term, or the first n terms of just I, is going to be the number of boxes times the number of boxes plus 1 divided by 2. And then if you have a constant being added n number of times, it's just going to be that constant times the number of boxes. Alright, for Andrew Kong especially, because you weren't here with us this last time. Let me see your face. No, let's see your forehead. There's your eyebrows. There's your eyes. Nope, lost the eyes again. Okay. Tell me, does this look familiar to you? Okay. Just want to make sure. This summation notation, I was pretty sure you've covered it, but I don't know how much time you spent on it. But, oh, by the way, Andrew, you will need to pick up a book from the office. But I'll talk to you about that later. Okay, so now these are just numbers. You could plug them in the calculator if you wanted. I'm going to go ahead and do some things by hand, because there's some things that I notice at Ames, students aren't usually very apt to cancel before they multiply. So I just want to focus on that for a minute. For me personally, one of the tricks my math teachers taught me when I was in school is to look for opportunities to divide before you multiply, especially when you have a lot of stuff like we have here. And so instead of multiplying 5 times 6 times 11 and then dividing by 6, look for opportunities to say, hey, there's something the same on top and on bottom. Because it makes the math a little bit easier, especially if you don't have a calculator with you. And for the AP test, you're not going to have a calculator for the entire thing. And so the same sort of idea here. I'm actually, let's see, I'll cancel this out with the 2 that's on the outside. So then we're just left with 5 times 6, or 30. And then let's see, for me personally, I like to, in this case, I'm going to put my positive numbers together first. So I have 60 minus 30, or just 30. So now I'm going to go back to the original problem. And I can substitute that in here. And then that last summation again is just we're going to sum a constant number those 5 times. And I'm going to keep doing my trick of I'm going to look for opportunities to divide before I can multiply. So for example, this 30 here, that's going to be really the only case where I can see something that will divide out, because I know that 30 is divisible by 5. So if I divide 5 out there, I'm left with 6. And here, when I divide the 5 out, it goes away. And the tops go with the tops and the bottoms go with the bottoms. One reason that I do recommend personally that you practice doing these numbers by hand is at the calculus level and above, we actually use a lot of fractions that sometimes don't have the numbers involved in them. There's sometimes variables, but just the whole idea of knowing how to use fractions is going to be a really useful skill. And so for me, if you from time to time practice writing everything out by hand and what that means, you're going to be a little bit better off in your math and physics and such classes, your chemistry. Because at this point, has everybody here had chemistry? Let's see, Nalina, you probably haven't yet but most people here. Unit conversions. Unit conversions are all just knowing your fraction rules. In chemistry, sometimes they call it something else. Dimensional analysis, I think. Converting from moles to grams and all that. It's all just fraction rules. The more that you practice fractions, the more you're giving yourself an advantage in classes like that. All right, anyway, let's see. 24, 48. And then my fraction rules say I need to have a common denominator. And when I did the problem up there, I did it slightly different. And if you're new to me, one thing you will learn is I am good with algebra, I'm good with calculus, and lousy with arithmetic. Oh, hold on. This one did not have a 25 underneath it to begin with. Oh, hold on. I see where I made a mistake. And instead of erasing it, I was just looking at my work and I'm going, this isn't the same answer that I got before. Here, notice I went ahead and I accidentally multiplied 5 by 5 and then I multiplied by 5 again. This should have been just 5 times 5, not 5 times 25. I apologize for making a mistake, but at the same time, I don't apologize because it is valuable to see where our problems lie. So these steps are all going to be still the same, but the answer we're going to get here will be different because I accidentally multiplied by an extra 5. So this will still be 125 here. All right, let's see. Alright, so I feel like I've been getting used to doing longer problems, but at the same time, I do think that these problems, when it comes to the algebra parts of it, can sometimes feel longer even than the problems we've done. You are welcome still to grab a calculator earlier on, but like I said, I do recommend that you play with just doing this by hand because doing it by hand will help you in other places in your math and math-based classes as you go. Alright, so I was going to do one more problem for you, but that one took long enough that what I'm going to do is I do want to start the homework with you, and I do want to do it with you. So I'm going to use that as my next problem. While you finish up this, I'll pull up your homework assignment. Okay. Pick 2 problems I'm going to do with you. And then remember, if you do get stuck, is today Thursday? I think today's Thursday. It is? Okay. I can't keep track anymore. Remember, I do have office hours tomorrow, and if you can't make office hours, just let me know and I'll still work with you. And I did make this assignment due Sunday, so you could also have the weekend to work on it. But again, if you need more time, just let me know. Alright, give me a thumbs up if I can scroll the screen. I didn't see... Okay, give me a thumbs down if I can't. There were a few people I didn't see thumbs from. Okay, nobody's giving me thumbs down, so I'm going to go ahead and scroll. How are you guys feeling so far? We'll use calculators for the next ones. It'll make it go a little faster. But I can see in your faces kind of the fatigue, either because it's Thursday or because it's a really long problem. So, by the way, you remember how we organized you into study groups? Everybody except for Lala and Andrew, which will put you in study groups. I do want you to keep using those. Even though I'm back, please do keep using your study groups. And then for everybody who's on the Discord group, Aurora, that's okay. I'm going to do the problem for you. Everybody who's on the Discord group, you know that every once in a while I chime in on the Discord group, and there was even one homework assignment while I was out on maternity leave where somebody said, hey, I need help with this number, and I got on and I did the whole problem on my phone and sent the file over. I'm willing to do that to help you guys out. So if you are on the Discord group, I don't remember who was heading up the Discord group. Was it Cormac? Cormac? Okay. If you guys want, you can put that in the chat so that everybody that wants access to that can go back and access that. That is something, these study groups, for your class especially, I do want to utilize those the rest of the year. Okay, so for your homework assignment, and this is on assignment 21.2, it's on page 268, and this is the homework assignment. And we're not doing any word problems, it's just some practice with these concepts. I will do problem 35, and if we have time, and I think we will, I'll also do problem 39. Yeah, Cormac, if you'd send that, and I think I've got it set, so let me check. Yep, you can send it to everybody. Perfect. So anybody that wants access to the Discord group, Cormac just sent that. All right. The worst part about these will still be the interpreting, and that's where I want to really step in and do everything I can to help you. Okay, so problem 35 says use the summation notation to rewrite the expressions without sum notation use the result to find the sum for these different number of n's. And remember, n equals the number of boxes. So we're going to have our expression, but we're just going to divide it into more and more and more boxes, but still in the same same region, but although this one, the function isn't given to us as a function, so we don't have to worry about that. Alright, and for problem 35, we're doing the sum of, from I equals 1 to n, of 2i plus 1 over n squared. So this is just practice using those summation notation, those 4 rules that I gave you last time in your book. Give me a second to get to the right page. In your book, they're found on page 260. Right there, all backwards in my camera. I gave them to you in the last lesson. Andrew, I'll give... Well, actually, let's go ahead and give them to everybody again. Just in case you don't have your notes on you from last time. So we gave you these 4 rules last time. I've already used them once today. And Andrew, it sounds like you're familiar with them, but just in case you don't remember them. And for Andrew Kong and for Lala, since you're both new to the class, everybody else is pretty used to it. Just so you know, we do go over synchronous time on a regular basis, just because with AP there's so much we have to get through. So kind of like with your U of U classes, just kind of, I'll still try to let you out before 10:33 to give you a little bit of extra time, but just know we do go over, like my bell just went off for synchronous time ending. We do go over that pretty often. Alright, so I want to be able to use these rules to change the way this looks. And that's all I'm doing, is that I'm changing the way it looks. So, legal moves. First of all, it's the things with I's that need to stay in summation notation. But the n's can be factored out. And anything you can factor out is a legal move. So the first thing I'm going to do is I'm going to pull that n squared out. 1 over n squared, rather. I do need to make sure it stays in the denominator. I'm going to have to write small because we're close to the end of the page. And then I'm going to play with these functions to try to get them to look like one of the rules that are over here on the right. So for example, I see I'm adding 2 things together. It makes sense to me to go ahead and give each of them their own summation. And again, if I'm giving this too many steps for you, I love that, because I just want to make sure I don't lose you in all this writing, because this is a fair amount of writing that we're doing today. And before I actually convert the summation notation, I'm going to pull that 2 out as well on its summation. And now what I love about this is now my summations look like the rules. I play with them until I can get something that looks like the rules. And then I replace the summation notation with the with what it equals. And then it all becomes an algebra problem at this point. I mean, really, all of this is algebra anyway. It's just an algebra that you don't necessarily see in your algebra class. I am breaking my own rule here. I'm doing 2 things at once. But I think you can follow along with that. I'm going to be creative about my equal signs for a moment. And I'm going to leave it to you to plug in the numbers and find what that equals. So you'll have 3 more problems in the homework that look like this one. And again, if you get stuck on anything, I'm not expecting that you see it once and you're going to be a pro at it. If you get stuck on anything, send me an email or put something in the Discord. In the Discord, what's nice is everybody has access to everybody that's in that. So there's a lot of times I usually only jump in if nobody else jumps in. And let me also remind you, the more you teach a subject, the more you learn it. So don't be shy to say, well, I think this is how it goes. Because you'll learn the subject more deeply yourself every time you help somebody else. I'm watching your eyes to try to figure out if it's a good time to move on. You can see a couple of you are looking down. I'm assuming at your phones because you're looking down and then nod up again. Give me a thumbs down if you're still copying notes. Alright. Okay, I want to do one more problem for you, and this one is different than what we've done before. You'll have 5 more problems that will look like this one, and it's really just taking 2 concepts that we've done and putting them together. We're going to do a problem like this, but then we're going to take a limit instead of plugging in specific n values. So, everybody take a stretch break, because I know I'm hurting your brains today. Get your stretches in. Come on, let's see ya. Everybody stretch. Most of you are in your rooms by yourself. Nobody's going to see you. Get the blood flowing. Get ready for this next problem. Do what you need to do. Stand up. Shake it out if you need to. Absolutely okay. Now, ignore the limit portion for a moment. Just focus on the summation notation. I want to give you guys a head start. I want you guys to go ahead and I want you to start playing with the summation notation with the idea of let's try to find what the how we can rewrite the summation notation and use those rules. And I'll put those rules back on the screen. It'll cover up the problem for a moment. Here we go. That's not so bad. Oh, come back. That's not what I wanted to do. Oops. More difficult than I thought just to show you this.
Hi there. Hi. What's going on?
There we go.
Go on with it. You want the pinky?
I think that there's one in his bassinet up near where his head goes. Oh, and there's actually one in the crib that's underneath stuff. Okay, so be playing with the summation notation and trying to rewrite it. I'm giving you a head start, and then I will work the problem with you, and we can compare answers.
Be back. I'm just gonna take my meds.
By the way, Jared, I haven't gotten after you, but why is your camera off? Trisha, that's absolutely okay. Yep. Just let me know if you have any questions as you get through this assignment, especially since we haven't done a problem like this together yet. I am recording this, so I'll put this video up as soon as we finish, but let me know if you need anything. Okay, see ya. Alright, and I've got the rest of the problem there on the screen, so compare your work with mine. If you're stuck, maybe mine will help give you a clue where to go next. If you have questions, please let me know, because it's the first time we've done one like this. And it's been a little while since we've taken these limits in this way. So if you want a refresher on that, just let me know. Oh, Jared, I just saw your message. Yep, that's fine. Thanks for letting me know.
Did a mess. You did a mess.
Needs a diaper change already? Okay. I am going to, in a moment, go ahead and take roll so that if you do want to go off, you can go off. If you want to stay and ask questions, I encourage you to. Before I take roll, though, a couple things. First of all, while we don't often talk out math, the more you communicate math with other people, the more deeply you'll learn it yourself. So again, please, while I'm not going to grade you on meeting with your study groups, you will understand this better if you are meeting with your study groups. Okay, and like I said, that Discord link that Cormac sent out, everybody's welcome to join it. I've got Discord on my phone because of the robotics team, and so I do see when messages are sent around. And while I don't jump in certainly on every problem, I am more than happy to jump in if you guys need something.